Okay, let's dive into this. Welcome to today's Explainer, where we're going on a seriously fast-paced, documentary-style journey through the technological evolution of the keyboard. We're going to see exactly how we went from these heavy, constantly jamming metal levers all the way to hyper-intelligent magnetic switches that literally track your finger movements down to the millimeter. It's a wild ride.
But before we trace that timeline, we've got to start with a kind of mind-bending question. Was the layout of the keyboard you're probably typing on right now actually engineered to slow you down? Well, the shocking answer is yes, absolutely. That familiar QWERT layout was intentionally designed to hinder fast typists. And to understand why in the world they do that, we have to rewind over 150 years. Jumping right into our timeline, we kick things off in 1868 with Generation 1, the mechanical typewriter. Before this, you wrote everything by hand, which was incredibly slow and prone to error. This first machine didn't talk to a computer or a screen. It was a purely mechanical beast built to press physical levers and smash wet ink directly onto a piece of paper. The physical chain reaction here is actually pretty fascinating to think about. You press the key with your finger, right? And that physical force drives a metal arm, called a type bar, which swings up to strike an ink ribbon into the paper. So it's finger to key to lever to ink to paper. Honestly, it was a brilliant physical interface for its time, but it required a ton of physical force. Plus, it had a massive, glaring flaw. It jammed, constantly. See, the earliest typewriters just used a simple alphabetical layout, but fast typists would hit neighboring keys so quickly that those metal type bars would collide midair and completely lock up the machine. So the inventor, Christopher Latham Scholes, came up with a real problem-solution irony that totally changed history. He took the most commonly used letters in the English language and spaced them out. Why? Simply to physically slow people down. That layout is QWERT. And it was so good at preventing those mechanical jams that billions of us are still using it over a century later. Wild, right? Now, what's really interesting about Generation 2, which basically ruled from 1880 all the way to 1950, is that they didn't try to reinvent the wheel. Instead, they just relentlessly refined it. People were frankly tired of sore fingers and loud clanking machines, so engineers focused entirely on reducing that physical effort. They introduced stronger springs for a much lighter touch, and they added the Shift key, backspace, tab, and, this is absolutely crucial, visible typing, meaning for the first time you could actually see the ink hitting the paper in real time as you typed. But even with all those clever refinements, typing was still physically exhausting, not to mention incredibly noisy. So enter Generation 3 in the 1950s. We finally pivot away from pure human mechanical force and introduce electric motors. Think of this transition sort of like introducing power steering in a car. Suddenly, you barely had to tap the keys, and a motor stepped in to do all the heavy lifting for you. It was a total game changer. And the absolute crown jewel of this electric era was the legendary IBM Selectric. Instead of a messy tangle of metal arms, IBM used this brilliant, spinning metal golf ball. You tap the T, the motor engages, and that ball instantly spins to the correct letter and strikes the paper. Because there were no separate arms swinging around to collide with each other, jams were completely eliminated. Plus, you could literally just pop the ball out to instantly change your font. Okay, let's update our timeline and take a massive leap into the 1970s. The digital revolution sparks Generation 4. Computers are becoming common, which means keyboards no longer need to physically hit paper. Instead of printing letters, pressing a key now sends an electrical code directly to a digital screen. And this right here is the true birth of the modern computer terminal keyboard. Now, because this new digital interface required us to talk directly to software instead of a mechanical carriage, an entirely new set of keys had to be invented. This is the era that gave us the function keys, the escape key, control, alt, and of course, the arrow keys. The keyboard transformed from a typewriter into an instantly responsive, fully programmable digital bridge. But there was a glaring flaw with this early digital setup. Putting an individual, complex electrical switch under every single key was incredibly expensive. As personal computers started exploding into homes in the 80s, manufacturers desperately needed a cheaper option. And this birthed Generation 5. They swapped out those costly individual switches for highly affordable, lightweight plastic layers. Enter the membrane keyboard. If you peek inside one of these, you quickly see why they were so cheap to make. There are virtually no individual moving metal parts. You press the key, a small rubber dome collapses, and it pushes a top plastic membrane down into a bottom one, which completes the electrical circuit. Manufacturing costs absolutely plummeted, making these keyboards ubiquitous in offices and schools everywhere. But, as you might know from your own experience, squishing rubber together results in a pretty terrible, mushy feel and really low durability. So, the crucial point here is that by the late 90s, the people who were typing all day, like programmers and PC gamers, were completely fed up with that mushy plastic feeling. They wanted precision back. And this sparked Generation 6, the modern mechanical keyboard renaissance. We're talking a return to form, where each key once again received its own dedicated precision-engineered switch. The driving force of this whole renaissance was the famous Cherry MX switch family. They realized that different typists actually want completely different experiences, so they cleverly color-coded their precision switches. You had red for smooth, linear gaming, blue for a loud vintage typewriter clip, brown for a quiet tactile bump, and black for heavy typists. For the first time, users could finally customize exactly how their board felt and sounded. 100 million. Just think about that number for a second. That is the staggering key press lifespan of a modern mechanical switch. This insane level of durability, paired with that unparalleled typing feel we just talked about, is exactly what justified the premium price tag of mechanical keyboards over those cheap membrane ones. But while desktop users were absolutely loving this mechanical boom, the laptop industry was facing a serious physical crisis. Laptops demanded ultra-thin chassis designs, and those mechanical switches were just way too tall. This forced engineers to get creative and invent Generation 7, the scissor switch. It uses this tiny crisscross plastic support that stabilizes the key and keeps the physical travel distance incredibly short. Yes, it sacrificed that deep tactile feel, but it gave us razor-thin portability. Okay, but what if you're an esports professional, where literally every millisecond matters? See, even the very best metal contacts in a mechanical keyboard will eventually wear out, or they suffer from tiny electrical delays called debounce. To solve this, 2015 ushered in Generation 8, the optical solution. And this is so cool, it uses the literal speed of light to completely eliminate physical electrical wear. The way this works is actually brilliant. Inside the switch, an infrared light continuously shoots straight across the housing. When you press the key down, the plastic stem drops and physically blocks that light beam. The exact split second that light is broken, the keyboard detects the press. It's completely frictionless, it's lightning fast, and it boasts zero electrical wear. Yet engineers pushed even further. They asked, what if a keyboard didn't just know when you pressed a key, but exactly how far you pressed it down? Enter Generation 9, the Hall effect sensor. So instead of light beams or metal contacts, every single key contains a tiny magnet. The sensor underneath continuously measures the exact downward distance of that magnet, literally tracking it down to fractions of a millimeter. Moving from a simple on or off switch to tracking actual physical depth enabled some mind-blowing features. I mean, you get adjustable actuation, meaning you decide if a key triggers with a feather touch or requires a deep press. It gave us rapid trigger, which resets the key the exact millisecond you lift your finger, which completely broke movement mechanics in competitive gaming. You can even use the keys for analog input, just like pushing a joystick on a controller. Which brings us to the present day, Generation 10. Because the physical actuation of switches has basically been perfected by optics and magnetics, the focus of the modern era has shifted entirely. It's really no longer just about the hardware. It's all about smart software. Modern keyboards are practically computers themselves at this point. They maximize productivity with dedicated AI assistant keys to launch copilots instantly. They feature massive onboard memory profiles, per-key RGB lighting, seamless multi-device wireless connectivity, and even hot swappable circuit boards. That means you can literally pull out your physical switches with tweezers and change them on the fly. No soldering required. The whole shebang is about deep personalization and intelligent workflow integration. Looking back, it's just been an incredible 150-plus-year journey. We have relentlessly evolved from heavy, clinking metal machines designed simply to smash ink onto paper, all the way to wireless, laser-precise, intelligent digital bridges that integrate seamlessly with AI. Through every single era, the keyboard has solved the problems of its predecessor to remain humanity's primary tool for digital communication. Which leaves us with one final, pretty provocative question. Since physical switches have essentially reached near perfection, what comes next? Will our kids be typing on holographic projections that predict our sentences? Or will the keyboard eventually just disappear entirely, replaced by direct brain-to-computer interfaces? Honestly, until then, the deeply satisfying click of a great keyboard isn't going anywhere. Thanks so much for joining me on this explainer, and I'll catch you in the next one.